Hello and welcome everyone to SQL Friday. This is SQL Friday number 38 and our star today is Cedric. Let me do a shot at your last name. Cedric Charlier, right? Probably not the best French pronunciation, but we'll see. Cedric is an architect and works in the business intelligence domain, and he is going to tell us all there is to know about Azure Databricks, or at least for me as a complete noob when it comes to Databricks. I think I will catch some of it this session. It's for me it's kind of a giant living in the hillside. I don't know what it is. I know it's good. People who use Databricks are impressed by it. So, Cedric, impress me. The stage is all yours.
Thank you very much. So this session is really about Databricks. This is not an advanced session about Databricks. This is mostly an introduction session for people who have no knowledge. So Magnus, it's really for you, this kind of session. So if you have any question, just ask them in the chat, because Magnus will just interrupt me just to be sure that I answer your question. So feel free to ask any question. It's absolutely not a problem. And don't wait the end to be sure that I answer your question. Just put it in the chat. Thank you. So, hi. So, as Magnus said, my name is Cedric Charlier. I am from Belgium, but I am French speaking, so you will have my accent during the whole session. I'm really interested by everything around agility, especially agility on the data warehouse and the quality also. So, to be sure that my goals on agility and quality, I am a big fan of everything automation. And it's also the case for Databricks. And it's also a bit of a reason that I jumped to Databricks. We see some stuff such as the different notebooks and so on. This is a great experience if you want to be agile, but the quality, and you have some way to automate quality, and that's really good. In terms of interest, everything around data. So I'm a full scope in terms of data. It's data modeling, data engineering, and so on. And about my experience, that's 15 years that I'm playing with data, 30 years for programming. And I am not a consultant, so I am not trying to sell myself because I'm not available on the market. I'm working internally for Azure Group. Azure Group is a company in Belgium to ensure everything about transport of electricity. So it's a really interesting market with a lot of data. In terms of contribution, I have many things on GitHub. If you want to take a look, many things around quality and automation. Okay, I am an MVP since now 7 years, VP of a data platform from Microsoft, but I'm also playing with other platforms such as Neo4j and this kind of thing. So I am not 100% player of Microsoft. So let's go to the topic. The topic is really about Databricks, and usually the first question when Okay, I'm back.
Yes.
Yes, I think that is gonna be better because I'm a 4G. I will have no problem with my wife also. Good.
Okay. No problem.
Let's hope it's going to be better. So I'll just restart on that. So Spark or Databricks. So there's a big difference between Spark and Databricks. So Spark is mostly an open source system. So it's an Apache 2.0 thing that has been developed since a couple of years. And Databricks is not really open source. It's based on Spark, Spark being open source, but not Databricks. It's built by the same developer on Spark and also by Microsoft. So it's a co-shaping of the future. So they started on Spark and now they are moving to Databricks. There's still new features.
Cedric, you're not sharing screens anymore. Can you share the screen as well?
Sorry.
No worries.
Oh, no problem. No, not the PowerPoint slide. This one, screen one. That's it. I hope that now it will be okay.
Perfect.
So let's continue. So as I said, Apache Spark is really something that is really interesting because it started as an open source project and moved it to Databricks. Now, what we need to know is that a lot of funding is into Databricks, and the new things are on Databricks. And we really need to move to Databricks because Spark is a bit complex. Also, Databricks has been really designed for everything around the cloud and specifically around Azure and AWS. So, which target is for what type of targets for the different users? We have different kind of user who could use Databricks. It could be a data scientist, it could be a data engineer, and a data analyst. So it's not just a tool for data engineers. So you could do more advanced things or more different things with data science. You can do some simple things such as for data analysis. But here during this meeting, we will just focus on something that is for the data engineer. So the first thing that you really need to know about Databricks is that the runtime is something really important. So as I said, the runtime is based on Apache Spark, and it's natively built for Azure and AWS. What does it mean to be built for Azure or AWS? It simply means that we hide the complexity of the infrastructure. So if you want to run a Spark cluster, it will be really complex because you need to manage everything around the cluster. So you need to manage everything about the hardware and so on. And it starts to be really complex. If you have already tried to use stuff such as Zookeeper, it's really, really difficult. So the good thing with Databricks is that all this complexity is completely hidden, and it's only in the hands of Microsoft or Amazon. So you don't need to care about providing a cluster and so on. It's done for you. So really the first steps are easier with Databricks than if you start on your own computer with Apache Spark and so on. The engine also is a bit faster when you use Databricks than Spark because all the optimization at the I/O level and computation management have been improved by Microsoft or Amazon to be sure that it's really efficient based on their own file system and so on. So really a bit of improved also in terms of performance. You also have a few libraries that are just available into Databricks and not on Spark. So this is a bit of a difference. If you go a little bit deeper into the architecture of Apache Spark or Apache or Databricks in that case, you will see that we have four big blocks. The four big blocks are really important to understand what you can do with Databricks. The first block is really about the Spark SQL and the data frame. This is the main block. This is the main block that all the data engineers will be using. This is what will enable you to really play with data frame. What's a data frame? If you are not used to this term, a data frame is just the equivalent to a SQL table or a relational database table. So it's really something that you should imagine with different columns and with different rows. So this is something that is relatively easy to understand, and you will be able to do all the manipulation on this table. It means that you can transform the rows, you can aggregate, you can also join to another table and so on. Everything is into this package around the data frame and Spark SQL. But if you want to go deeper and if you want to really embrace the future, you should take a look also to the streaming part. So the streaming part is a different block, and in this block you will be able to receive data on a continuous flow. So it's not that you read at one moment and that you have a picture of that moment. No, you continuously read and you get the new information that are coming to your stream. So this is also something that we will touch a few words at the end of the presentation. You have other blocks also. The first one is about machine learning. So this is not something that we will touch today because it's ready for data engineering today. But you need to know that in Apache Spark or in Databricks, you can do really good stuff with machine learning. So it's also a platform that is enabled for this kind of workload. And the last one is about graph computation. I am a huge fan of everything around graph database and so on, and I can say that really what we have in Apache Spark on the graph computation is really great. If you want to make a lot of work on the graph and so on with a huge workload, this is really a tool that is interesting, and this is also something that has a lot of traction at the moment and a lot of new developments and so on. So really an interesting part. So that's the four big blocks. A bit, you see what you can do with these four big blocks. It's not just because it's different blocks that you can combine them and so on. And naturally, you can combine them and you can combine streaming with data frames. It's something that most of the people are doing on a daily basis. So it's not completely independent, and it's really a platform. It's really a platform, and you need to understand that you can use this platform with different language. So you can use this platform with R, SQL, Python, Scala, and Java. Naturally, and especially for R and SQL, it's not necessarily the R and the SQL that you are used to. You have some limitations, it's a bit different and so on, but mostly you can do a lot of things with R, SQL, Python, Scala, and Java. The 5 languages are at the same level, so it means that everything that you can do with you can do it also with SQL or Python and Scala. And why are we sure about this? It's about the architecture of the platform itself in terms of language. As I said, we have four interesting building blocks. And the 4 building blocks are really the Apache Spark core. It's where all the functions are developed. But if you take a look on top of that, there is just something that is a Scala API. And in the Scala API, you can call all the Apache Spark core. So you just need to reach your Scala API to be sure that you can use the different components. And to be sure that you can use that with any language, we have put an interop layer on top of, and the other languages such as Spark R or Python or Spark for .NET and everything are using this interop layer to access the Scala API and to use really the libraries that are put at your disposal into Apache Spark. So this is why, in fact, you can use many languages with the platform, and the language has exactly the same features because everything at the end is relying on your Apache Spark core. In terms of performance, you have a small amount of time that is spent into the interop layer. So if you are not developing in Scala, you will have a small amount, but it's usually less than 0.1%. So it means that if today you already have some skills into Python or into SQL and so on, you don't need to learn Scala. And you don't need absolutely to get the best performance to code in Scala. That's a bit stupid. You would be much more efficient into a language that you know, such as SQL or Python, and please continue to use them. There is no big difference between the performance of a language and another one. Everything at the end is just in the Apache Spark core, and so it's exactly the same performance. Okay, so when we are speaking about Spark or about Databricks, we are speaking also about about a cluster, and this cluster is something really important. You need to understand a bit of the architecture of Databricks or Spark. Databricks or Spark has different nodes, and is trying really to split the work between the different nodes. So this is the main idea of Spark, is that when you have 20 computer nodes, it's really faster to distribute a little bit of workload on every node and then collect everything back to one node. So as I said at the beginning, creating this kind of cluster in Spark is a bit complex, and you need a little bit of knowledge about the infrastructure and so on, and it takes time to master this kind of thing. In the case of Databricks, everything is fully managed by Azure. So it means that I don't really need to create the cluster, I just need to activate it. And it's created in a few seconds, except when you try to make a demo, it takes usually a few minutes, but just a joke. But really, if you want to create a cluster in Databricks, it's usually less than a minute, and you have a cluster that is available. A cluster that naturally you can scale. It means that you can say, okay, I just want 2 nodes because it's just for a little workload, or I can create one with 8 or 20 nodes if I want. Okay. You need also to understand that your cluster would be dynamically scalable. So what does it mean? Even if you have 16 nodes and you start something that is relatively small, the 16 nodes won't be into action. Only a few of them will be into action. And if at the end the cluster is saying, oh, it's much bigger than what I was expecting in terms of workload, I could perhaps create additional nodes, or I could use additional nodes, then the cluster will be expanded by itself. So new node will be activated. Naturally, you can put a limit. You can say, oh, hey, guys, don't go further than 32 nodes, because it has a cost also, naturally, to use those kind of nodes. And so you can limit somewhere the invoice at the end of the month. If you want to play with this cluster, you also have an API, so you can do it with another application or PowerShell script or anything that you want. You can really dynamically size also your cluster. Another great point of using Databricks and not Spark is that you are updating to the latest version. This is something when you have managed a Spark cluster that is really interesting, because it's really a mess to update from a version to another if you want to do it manually with Spark. The good point with Databricks is that it's done by the engineers of Microsoft for you, and so you just need to use a drop-down and select the latest version, and it's running. Pay attention that it's Spark, and Spark is not usually really good to go from one version to another. You have some compatibility issues between the libraries and so on, but we will come back to that later. So don't really go to production and just say, hey, we will switch to this version, to the next version, because it's just available since a few days. You could have compatibility issue, but at least you don't need to rebuild all your cluster and manage the different versions on by yourself. It's done by Microsoft, or if you go to Amazon, by Amazon. I was speaking before about the libraries. So Spark is coming with a feature that you can add additional libraries, especially in Python or Scala. So you can use some libraries that are available on the market, and you can do that. You need usually to add a lot of libraries if you want to do some complex stuff, because the cluster is light by default. So it means that by default it's not coming with external dependencies. You just add the dependencies that you want. It's really good practice. You don't get them with something that is overloaded already. No, you just need a few libraries, just install them. The versioning is crucial, because usually those libraries are compatible with specific version of Spark. So usually when you have a new version of Spark, you can't really use this kind of library. You need to stay with the current version, and a little bit later they are updated to match with the latest version of Spark. So it's true that the clustering and the fact that your Databricks are really good, but still pay attention to those external libraries that are not embedded into Scala, or you could but are not embedded into Databricks, or you could have a few issues. But globally, it's a really, really nice feature, this cluster. It saves you a lot of time. So how people are really developing into Databricks? That's the next question. And for this, they are using notebooks. Notebooks is really good, especially when you develop and so on. So I will just show you what's a notebook, because some people never know what's a notebook, or they just think that it's a computer or a kind of laptop, but it's not the case. So this is, in fact, what is a notebook. So a notebook, you will see that you are able here to mix between text, you have some text here, and you have some code there. That's the first big feature. So it means that globally, you can really comment the code that you are making and so on. If you take a look to the code, you will see that we are able to use different language. Here we are using just Python, but if I go a little bit further here, I am just using SQL. So you can really jump into a notebook from one language to another one. So that's really something interesting. You are seeing also that in a notebook, you have the code, but you can also execute the code, and you will have the results that are also available into your notebook. So it's really one only environment, just one page where you will be able to see the different things, your comments, your explanation, and so on, that you can edit, but also the code that you can edit, and the results that are already embedded into this page. And it's not just table that you can display, but as you see, we are also able to display charts, and it's something that is really, really interesting. And you can change also the chart with the plot options and the different options here to have pie chart, to have a box plot, and so on. So this is really a full environment when you can do a lot of things with data. You are not limited to code. You can mix code, text, charts, but also tables of results. And that's a really cool environment when you are starting, because you can really explore the data, review the different things, and so on. In terms of demo, we will come back later to the execution of this code and so on, but I just wanted to show you a little bit what's a notebook for a few people that don't know it. So you will have really a lot of interaction with this code and those data. So the idea is really that you execute a cell of code and that you just receive the different data. The point with those notebooks is also that you can re-execute 20 times the cell, and it's not a problem because the result of the previous cells mostly stay in memory, and that's something that is really very cool. Okay, you can use also those notebooks for everything around interactive dashboard and dynamic reporting, as it means that you can also exchange those notebooks with your end users. I wouldn't recommend to do that with your CIO or CEO. It's not the goal, but if you have data analysts and so on, they can really interact with your analysis and just deep dive into the different charts. Okay, the plotting system is not limiting to everything that is embedded into Databricks. You also be able to add some libraries such as D3, ggplot, or matplotlib just for visualization, and that's something that is relatively great. You can have great charts with that. In terms of security, it's also a concern of many people because I'm speaking about notebooks and so on. So could everybody access your notebook, change your code and so on? If you are doing ETL, you probably don't want this kind of thing. Now, just be sure that the security is something that is really embedded into Databricks. So you have a full integration with Azure Active Directory. So it's not something where you manage the security and create user on your side. Now, full integration with Azure Active Directory. And you clearly have some roles on the notebook. So you have a role just to run the notebook, to read the notebook, to execute the notebook. And you get the same kind of roles on the clusters. So if you want to be able to define your cluster, you need a specific role. And if you just want that people consume the cluster that you put at their disposal, it's another role. Okay, you can also create jobs. So we'll see that just after. And you are able to manage security on that. About the scheduling. So if we want to do something that is mostly an ETL or an ELT, I won't go into the detail about the difference between them, you will need to schedule it. The good thing with Azure Databricks is that you don't need an external tool to schedule it. You just need to schedule a notebook. So if you go to here, you will see that we have jobs, and you can click on the jobs, and you will have the different jobs. And if you want to create a job, you can do it, and you will need to assign it to a schedule. So it's not really something that is difficult, but it's directly embedded into Databricks. So you don't need an external tool for the scheduling. Okay, just go back here. Okay, thank you. Naturally, it's not the only way to start a notebook. You can also start a notebook by using something that's really interesting, and this thing is Azure Databricks. You can really use Azure Databricks also for this, and it's a really good point because you can combine Databricks and Azure Notebooks without any problem. If you are a huge fan or other way to schedule the things, it's also possible in Azure Databricks. Okay. Oops, sorry. Is there any question at the moment? No?
No questions in the chat, no.
Okay, feel free to ask. Huh? It's just an interactive session. I don't think that we are 200 today, so feel free to ask your questions. Next part is about the data frame and the data set. So you really need a good understanding of data frame. So as I said before, if you don't know what's a data frame, never seen this word, you really need to use the image of something that is a table in SQL. You just mute someone because it's very difficult when you have noise like this. Thank you. A data frame is really a table. You have different rows, you have different lines. One of the points about the data frame is that it's immutable. What does it mean immutable? It means that we cannot change the content. But you can, in fact, apply functions, and those functions will create, in fact, a new table. That's a good practice in terms of development, because if you are looking a bit about the studies and so on, you will see that 80% of the bugs are due to the fact that some variables are mutable. So you have more and more language, such as it's F# or a new language, I would say, that are trying to move to immutable things, and it's really the way that we are changing the world today in terms of language of development. Okay, the data frame, that's from I would say theoretical or from a user perspective. It's just a table, but if you take a look to how it's implemented, the table is not just on one node. It's really split between the different nodes that are available. So in terms of physical implementation, the data frame is really split between the different nodes, and you can really apply the calculation on them. So it's not something that is physically at one place. Really, the distribution is on all the nodes. What are we able to do with the data frame? The main thing that you're able to do is transformation. And when you want to do an ETL or an ELT, you have a T that is standing for transformation. So that's really, really important that we're able to do this kind of thing. And what kind of transformation can we do? You can modify the type of a column naturally. You can go from a string to a double or a float. You can also create your own function. So it means that if you want to change all the A into a sentence by I or something like that, it's a bit stupid, but you can do it. You can create your own function doing that. If you just want to implement it, yes, feel free. You can create your own using functions. You can naturally do all the things about splitting a string and all the things that you can do with pandas and so on are available for the transformation of a data frame. You can create joins also, so you may say you can make some jointure between two different data frames to be sure that they are only creating one jointure. This is something that is especially important into Databricks because if you are a data engineer, you should know something about big data and so on. It's that we don't want that the end user is doing a join. In big data, we do the join as soon as possible. So we want to be sure that the consumer of our end data frame is having all the data that he wants and he doesn't need to do a join. Why? Because the join are really costly into big data. It's really not the goal to be able to do that. And so you need to do them into your ETL pipeline. So we don't try to do a normalization into big data, especially not normalization. We want to be sure that everything is into the table that the people will use. Naturally, something that you can do also is to chain transformation. So you can do one transformation, another one just after. Naturally, that's what everybody is expecting. How does it work behind the doors? It's optimized by a plan, an execution plan. So it's exactly the same that in SQL Server. You have an execution plan on all the things will happen. This execution plan is mostly about how the workload will be split onto the different nodes and how many nodes will be used for each of different calculations. You have also something that is called lazy evaluation. Once again, it's something that we see in more and more language, Power Query, F# and so on, also are lazy evaluated. It means that if you have a branch if then somewhere, if you have nothing going to the then this part of a branch will never be evaluated. So you can save a lot of time in some execution like this because part of a branch that don't need to be evaluated will never be evaluated. We just evaluate when we really need this. It's okay? So it's part also of the optimized plan that is calculated by Spark. So let's go a little bit to the code because we will see how it's working. So what you need to know is that you have some functions to read the different files or the different database. So it's usually spark.read. We are able to do some transformation with PySpark or something like that. So we will show the code for this. A touch of SQL also. I will just show a demo into that. Okay, so let's go here and we will just pray that everything is working with the cluster. So what do we have in this notebook? We just have, in fact, a file location. So I'm reading a file, and the file is, in fact, here in the file store. I'm just mentioning that it's a CSV and that I want to not infer the schema. So it means that I don't want to try to guess if it's a float or something like that. but the first row is really the header, so I should take that as the name of the column, and that the delimiter is a semicolon and not something else. Okay, so here I'm creating a data frame. DF stands for data frame, and for this I am just using the spark.read function. So what is happening in this this code? I'm just reading my file, just that, and I am displaying also the data frame. So this is just pure Python code. It's not really complex, and I can execute that just by clicking here, run the cell, and my cluster naturally shut down. So we will need to wait a little bit, a few minutes, no, a few seconds. Okay, but I will continue to explain a little bit the code to show you that it's really straightforward to understand the code in Python. So what I am doing here is just importing PySpark. PySpark is really something that is available into the Spark framework. So it's something where you can call a lot of functions regarding Spark. So where it's really the base library where the different functions are implemented to manipulate the data frame. And as you see, it's related to Spark. So if you are using PySpark, you are using the power to be able to split the workload between the different nodes. If you are just using something like Pandas in most of the case, but also NumPy or something like that, pay attention that it could be not distributed. So everything will be executed on one node, and you are somewhere losing a little bit the power of Databricks by doing that, because you cannot parallelize the workload with this. So pay attention if someone has developed something into Python and you try to move it into Spark, even if it's the same language, you need to be careful about the libraries that have been used, and you need to ensure that it's using the parallelism that is offered by Databricks. So what are we doing here? I'm just doing a bit of renaming, because if you take a look to the previous, yes, not really, it's not started, so you don't see it, but you have name of the columns that are just this kind of thing with the brackets and so on, and it's not really easy because you have space and so on, so we need to quote everything. Nobody liked this kind of column name, so I'm just a bit changing the name to be sure that we can naturally have something that is more intuitive when we will use this kind of column. So just renaming, and as you can see, I can change them. I just need to add a dot into them. Okay. Then for the next few lines of code, I'm just saying that I can drop a few columns that I won't use in the next part of my analysis. And for this, I'm just defining the name of all the columns that I don't want. And I'm just saying, okay, on the data frame, you need to drop those different columns. So really straightforward. It's not too difficult to understand. The name of the function and so on is relatively easy, and you can really move forward with this. Here, what I am doing is just displaying the name of the columns, so not too difficult. So the name of the remaining columns, in fact, that's what will be interesting. And if you want to see the results, it's available here. So I would just keep a few of the columns, and you can see that, in fact, they are being renamed into the first part. So what I can do, and it's where it starts to be really interesting to use a language such as Python and so on, I will say here the column 1 to 5 are really numeric columns. But in fact, if you take a look to the CSV file, it was a comma separator for the decimals, and it should be a point. And it was interpreted as a string because I didn't make any information about the different type. So I need to recast this as a double. So I am just doing a for each, in fact, here, for in, not really different than for each, and I'm just doing this kind of replacement. So really straightforward to move forward with this kind of thing, and it's something that is really interesting because I don't need to repeat 20 times the same operation, and so no, I just need to make a loop. Okay, the last part here is really about the creation of a replacement of a temporary view. So I will say you are making some transformation into all those code. That's really great, but now you need a little bit to process this into a view that I will be able to use in SQL if I want. So, and the view should be named WinForecast. Okay, so my cluster is now running. Good news. So a few seconds to be able to read this. We are live, so you can see that cluster is running. That's it, and I have my results. So now, because my cluster is running again, if I want to repeat the same command, you see that it's really straightforward and it's really faster because my cluster is now available, and my cluster will be available during the next 20 minutes, I think. So if I don't do anything during the next 20 minutes, my cluster will shut down. But if I'm using it, my cluster will still be available. So this is really the file that I had. So you see that we have comma for the separators. We have a not friendly name if you want to develop something. So this is all the change that I've done here. Different things also, as you see also, you have here date that is not really a standard date, and it's a bit weird, but I am changing this into a standard date here. Okay, so I'm transforming this to a timestamp. So that's a kind of function that are freely and easily available. And if I execute my second cell, wait. Okay, I have my results here. So everything is running. Take a few seconds. You can see that it has probably been parallelized somewhere. No, it's just one Spark job because it's a relatively small file. And you see that now I have a current date time that is really something that I can use as a date, and I have different double here. So it will be easier to make some aggregations and so on. As I said, here I have created a view, so something that I can use in SQL. And so I can jump to the SQL language. Okay, I just need to specify it by %SQL. I don't need to do it by Python because I created my notebook as a by default Python notebook. So when I don't specify something, it means that it's Python code, but here it's SQL code. And I can just do select star from WinForecast that has just been created into the step before into Python. So what's really cool about Databricks is that you can jump from Python code, where you can do a lot of transformation and so on that are really easy, and then you just step back and you say, oh, no, I don't want to use Python because I want to do a join and so on, and it's probably easier to do it into SQL. So yes, I just moved to SQL. So absolutely no problem. If I run this code, naturally, I should have something that is more or less the same, okay? But as you see, it's displaying the plot. It's just because I tell it to have, oh, sorry. Did I do? Yeah. Okay, so it's a table that is here. So I just said, hey, display a plot. So if I do it again, the line up, it's a plot. So it's relatively easy for everybody to switch between a table and a chart. It's just a couple of click on the user interface. It means that you can really analyze the different things. And here it makes sense to have this kind of thing for wind forecast. But if it was solar forecasting, it makes no sense. Okay. So that's it. So what can I do? As I said before, I can do some aggregations into also the SQL language. So typically, it's what I'm doing here, some aggregations, and I am creating a new table. This table, again, will be materialized, and I will be able to use it later. And it's just what I can do here. I can jump from SQL to Python. I just say, okay, select full content of this table and display it. And then I am back also to write everything into a Perky file. I can jump and write everything to a Perky file. So really a lot of feature to be able to switch between Python, SQL, and so on. You can jump also from CSV file to Perky file relatively easily. So that's really great about Databricks and Spark. Okay, and you can see that I can drop also the different things. If I want to execute that every night, it's not a problem. I do a job. I just assign in the job this notebook, and it will be executed every night. All the transformation will be done. All the persistence of the Delta format and so on, of Python format, will be done every night. So really cool environment to create this kind of thing. Any questions specific on that? Oh, I'm quite
nothing so far. No.
Probably because I'm too clear. So, so something that's really important when you're speaking about ETL and so on, it's what kind of file or what kind of source can I use to really get the data out of this environment. So you have a lot of files. You have Avro, Parquet, CSV. You can be zipped and so on. So you have a lot of common things. that are available there, and you can define naturally some variants, such as for CSV, it would be comma, semicolon, and so on. You can also naturally connect to many things about Azure and also Amazon, because it's mostly driven by Azure and Amazon Databricks. So you can connect to Cosmos DB, Data Lake, and so on. And if you are from Amazon, Redshift, Airfree, and so on. But it's not limited to that. You can also connect to your MongoDB, Cassandra, Neo4j, Snowflake. So it's really difficult to find something where Databricks can connect, and most of the case, you should really challenge yourself, why I'm using this database, but it's not connectable with Databricks. Okay, so there is no big problem at that level. You can connect to all your source. Based on that, I would like to jump to something else also, that is Delta. Delta is something that is really have a lot of traction at the moment also. It's something on top of Databricks, in fact. So this is really an ecosystem that Databricks is developing at the moment, and Delta is one of the leader into this ecosystem. So what's Delta? Delta is a transactional storage layer on top of Databricks. So you can really store all your data into Parquet file. So Parquet file is a columnar format, so that's something that is really good for aggregations and so on. The good thing with Delta is that you really have some schema enforcement and evolution. So you need to define the schema. So somewhere we are a bit in between, because in big data we say, oh, it's very cool because we don't need to define a schema. But we know that sometimes it's really good to be able also to have a schema. And it's why we are using Delta. You have ACID transaction. That means that you can write something without effect on readers. It's not the case if you are just using Databricks. So you have consistency, but it's not something that is 100% sure with just Databricks and simply a data lake while you are writing. The good thing with Delta is also that you will be able to do delete, updates, upsert, merge without interference. So you have atomicity. And you have also some kind of statistics, data skipping, Z-order clustering, and so on. So what does it mean? It means that you will have better performance when reading data. Okay, so you don't really have an index if you are used to what's an index into a SQL server or into Oracle. It's not really the same, but it's really close to what's an index, and it's enables you to read really faster. Another thing about Delta is that you will be able to do batch and streaming into the same table, and that's really cool. So how Delta is it really working? As I said, Delta is based on Parquet file. So you can say, okay, but if it's a Parquet file, what is different? In fact, what you need to know when you use a Parquet file and you are trying to update a row into a Parquet file, what's happening? In fact, you will read the whole Parquet file, and you will need to do a change in memory and then rewrite the whole Parquet file. So that's a lot of I/O just to update potentially one row or a couple of rows into your Parquet file, and that is taking a lot of time and a lot of energy. So this is absolutely not efficient to do an update or delete into a Parquet file. It's much more efficient to do an append, so adding a line, because you just need to add this line and you don't need to rewrite the whole Parquet file. But if you want to do an update, this is absolutely not efficient. So it's why Delta decided to not really write the update into the Parquet file, but it's updating, in fact, a JSON file, or creating a JSON file for any change. So if you want to read the whole content of your table, you will not really go to the Parquet file, but you will also need to read all the JSON files to be sure that you have all the latest change that happened. So it's really efficient in terms of writing, because you don't need to rewrite the whole Parquet file. It's just appending a JSON file. In terms of reading, you stay relatively efficient, because you have the benefits of a Parquet file, but you just have a few JSON files that are there. Not really if that was just the principle to add new JSON file. At the moment, you will have thousands of JSON files, and it will be unmentionable. And it's why, and sometimes you have a checkpoint, in fact, and all the JSON files are reconsolidated with the Parquet file to create a new Parquet file. So this is something that you can define or many times by day it happens, or you can say also that it's once by week. It really depends of how many updates you have, and it could be included also into your ETL. Okay, you also have a vacuum that is just doing that. It's what we are calling it at the vacuum. It's to create the checkpoint. So that's how it's working with the Delta, and it's really efficient if you need to do some updates and deletes to your tables. Are we stronger with Delta? Yes, surely, because we are managing files and not records. It's column-based also versus row-based, and column-based is really good if you want to do some aggregations, and most of the ETL or ELT or most of the analytical things really use ETL. Really use aggregations and so on. So column-based format is really good for this. You can handle the merge and the update, but it's not as fast in the transactional database. So don't get me wrong. I don't tell you to replace your transactional database that is supporting billions of updates, insert, delete on every hour by Delta. It's absolutely not a good use case. You shouldn't do that. But it's useful if you need to do ELT job that require a little bit of merging and updating. You have no reindex, but you have the different Z-order and so on that can really speed up the different things. And if you really need something that is more transactional database, take a look to Azure Cosmos DB and not really to Delta. Okay, so now in terms of architecture, what we could do and what we could have, it's really this kind of architecture. So you have your different applications and so on. You need probably to move your data to the cloud. Just do it with Azure Databricks. We are on the cold data, so it means that it's by batch. You do it this every night. Then you put that into a data lake, and you have your Azure Databricks that is reading, in fact, from your data lake, that is doing all the transformation that are needed, and just putting the export into SQL database or Azure Cosmos DB. And then on top of those, you can use Azure Time Series Insight, or you can use also Power BI or an SSIS model. So that's really the common pattern that you will see at many places. Data are written into a data lake. You have your Azure Databricks that is running from time to time, and that is transforming all the data and putting the export or in the data lake, but most more commonly into a SQL table that could be queried by Power Query or something like that. So that's one of the common architecture that you will see at many places for cold data. When we are speaking about cold data, the next step is to speak about hot data. What are hot data? It's really what we are naming also streaming. Streaming, it's just the information that are continuously moving to your table. So it's coming from a stream. So you have a sensor that is sending each second or from time to time different value, and it's added to the table, and you can continue read it. So streaming is just the equivalent of table within the NAND, and we have into Databricks some support for late arrivals on unordered data. That's a special case, and naturally you can have a sensor that's sending something during 20 minutes, and that will be just sending them later, and so on. So you need this kind of support. I won't deep dive into that today, but just know that it's not basic streaming, it's really advanced streaming with advanced features that are really useful when you really need to develop something for real life cases. So what's streaming? That you just have different information coming to your stream, and if you want to read them, you just need to think about an abundant table. So you just put them at the table, and when the next element will be coming into your stream, it will be added at the end of your table. So if you just read again your table, you will have this additional element. If you just did open the read, you will have this element that is coming from, and so on. So it's just a table without end until you let your stream open. Okay, so where can you stream data from? You can do it from files. It's usually not a good idea to do it, because usually you should use Kafka or Azure Event Hubs for this. So it's really the kind of ingester that really can capture the different events that are created by sensor or application, and that's creating a kind of buffer where you can really get the information from and read them with your streaming data pipeline. So if I'm getting back to an overview in terms of architecture, what can we do? We say, okay, that's the schema for the cold data that I'm displaying at the moment. If I want to change into hot data, the first thing that I need to do is to replace my Azure Databricks by Azure IoT Hub or Event Hub or Kafka. Okay, I need to be sure to do that. So I will still write them to a data lake. It's what we are naming raw data. So it's really the event that is coming, and you should put it to the data lake to be sure that if you have any problems later, you can restart from this point. It's any problem or any new ID. So you continue to write them to the data lake, but you are also directly sending them to Azure Databricks. So clearly, in that case, when you are using hot data with streaming, you don't read again from your data lake, you read directly from your hub. You have a second branch that is reading with data lake. And then you could also consider to use the change feed of Azure Cosmos DB. That's one of the possibilities also, and it's exactly the same. You can do some streaming. The point after that with Azure Databricks is that usually you write again to the data lake. So all the transformation that you are doing into Azure Databricks, based on streaming, you write again into Azure Data Lake, but you can write also the output to SQL and so on, where you can consume Power BI and this kind of thing. So that's globally the kind of architecture that you will build if you are doing something with streaming and with hot data. So you can support also both hot data and cold data at the same moment with a really good ETL process. Usually it's a good practice to do different things in hot data, but to do also a batch during the night to be sure that everything is working fine, and to be sure that if you have any problem during the day, it could be handled during the night. Just a short remark about data science. Usually what's happening with data science is that you have also Azure Data Factory, you write it to a lake, you use your Azure Databricks that is coupled with machine learning service. Okay. So just trying to reach the conclusions. So we have key difference with some other ETL. So if you are used to develop with SSIS and so on, please consider those different things. Databricks is really suited for immutable. So we try to transform everything into something that's immutable, so append only. You can use Delta if you have updates, merge, and so on. But still, you should really consider if you can transform it to something that is not immutable, so you append only. Join and updates, don't forget that it's a costly operation because the data will be distributed into several files, the column-based files such as Parquet. Updating the row means rewriting the file, so consider this kind of thing before doing joins or update. Something that could be also a bit weird for the newcomers is that we have no sequence generator. The reason is really simple, is that when you are distributing the different information onto the different nodes, it's really difficult to have a single generator that is operating on one node. It means that you need to synchronize everything, and at the end you are losing all the benefits of this distribution. Don't forget, normalization is an anti-pattern in big data. Why you should use Databricks? In fact, you have two main use cases, analytics on top of data lake, that's one of them, and data transformation in a data lake to a data warehouse or to a SQL database and so on. That's the two main use cases. You should really consider the total cost of ownership, because we have more and more cost when we use a data warehouse only approach. So if you want to do everything into SQL with huge volume that we have, your total cost of ownership will be really high, and it's why you should consider to use a data lake and Databricks. And finally, the conclusions. If you are using SSIS today, should you just do Azure Databricks for everything? The answer is no. Azure Databricks will never replace SSIS for structured data movement. So if you are moving from a relational database to another relational database, please don't use Databricks for this. Continue to use SSIS. Azure Databricks is also built for big data. It means that sometimes it's not so efficient as it could if you have a small amount or small volume to move. So please think about it twice. Do you really need Databricks? For me, we will continue to have SSIS and Databricks into most of the shop during the next 5 years. An error that I have seen in many companies is just say, oh, but it's not an ETL language, it's not an ETL language, it's just Python. So I can give that to any Python developer. don't do that. It's absolutely the same practice that you do with your Python code, with SSIS or something else. So all the good practice of data movements are still applicable to the code. It's not because you write in Python that you should forget all the rules that we have learned during the last decades about moving data. Streaming and batch are mostly equivalent. That's really easy to do streaming at the moment with Azure Databricks. So we need to be sure that we use it when needed. You have a nice integration with Azure. That's something that's very cool because you can source or sync any source of information. And finally, you have the notebooks. The notebooks is something, at the beginning, I was not a big fan. I said, oh, I need to code into a web page that's really boring and so on. But if you take a look at the end, it's something that is really interesting, the iterative approach and so on. It's something that we do often when we are building an ETL. And it's something that deserves, or at least that you try it once, because it's really a great environment. And that's it. Do we have any additional question?
Yes, we do actually.
Oh.
We have 3 questions. One is from Jovan Popovic, who is asking, I believe that Delta format will still write data in Parquet files and create new Parquet copies. JSON files are just pointers to the latest valid Parquet files, right?
Yes, that's correct. Jovan is, yeah. I was a bit, I take a shortcut. Yes.
Yeah, I get it. Next question is from Jussi, who is asking, does Spark support hashing of keys?
Yes. But I don't know what she wants to do, because this is really a really deep technical question. I'm not sure that we share the same definition of hashing on keys, because most of the time you will have different, the table will be using the Z order and so on. So you will be in different files and so on, and you don't need to read everything. So it really depends if it's for join or not, but globally, yes.
Okay. And last question is from Wim, who is asking, how do you handle the configuration of different environments in an automated manner when working with Databricks, reading from writing to a different data lake, just to give an example?
Yes, so that's something where so I know Wim, and I will take the question offline because we are already over. We are already late, but I will take contact with him to answer, because it's not so easy to explain in a couple of seconds.
Perfect. So with that, I want to thank you for coming to SQL Friday. It was really informative, really good overview of Databricks. So I think for anyone who wants to know what it is and get started, this session is a really good starting point. So thank you so much.